Hello, good morning, everyone. Welcome to this workshop of the DTOceanPlus project, in which we will talk about one of the outcomes of the DTOceanPlus projects and how we address one of the needs of the ocean energy sector, which is the need of a standardized approach for the description of ocean energy projects. The DTOceanPlus project is a European funded project with a duration of 40 months. We have just reached the end in August 2021, in which 16 partners from 7 European countries have taken part, plus the collaboration with 2 leading research laboratories from the United States. One of the outcomes of the DTOceanPlus projects was to produce a description of an ocean energy project in a standardized approach. Indeed, since from the proposal preparation, we were aware that the sector needs a standard method for describing the key characteristics and attributes of ocean energy technologies. This was indeed needed because at the moment there was not a unique approach to compare objectively different technologies, even competing. There is not a unified approach in order to analyze innovative designs, and of course the lack of communication can lead to somehow a waste of resources, which are already limited for the sector, and moreover, the presence of such a standardized approach will improve the share of the knowledge itself. For this reason, in the DTOceanPlus project, we aimed at solving this lack of the sector by using or by building a digital representation framework in which the ocean energy project will be described by means of digital objects. This, of course, if the sector and the industry takes as a basis for a standardized way of describing the ocean energy projects, will definitely facilitate data and information exchange, will enable comparisons in an objective fashion between various technologies, will enhance somehow the communication among the different actors, and plus it will define a common language and architecture for storing project information. The building of such a framework followed the same of any kind of project, all the phases of any kind of project life. We started from a general concept. We started analyzing with the main users. We developed then the concept, and finally we implemented the proposed solution, and now we are also trying to disseminate the work we have done. While building the concept, we kept in mind 4 guiding principles. The first one was that the digital representation for ocean energy systems must be flexible. First of all, in order to capture the different technology readiness levels of different technologies, from early stage, which lead to description of the designs at low complexity, to higher complexity, which corresponds to higher TRLs. Moreover, the concept we have been building hinges upon the expandability property, which means that should be flexible enough in order to accommodate room for other kind of new objects, case of, for example, novel PTOs, novel concepts, and also in order to go into deeper and deeper detail. The digital representation approach we have been building during these last 3.5 years. Also should be able to deal with different levels of aggregation, going from a more global context to array sub level, device level, and finally subsystem level. Moreover, it should be standardized enough in order to enable different actors speaking different languages communicate each other. This has been achieved through an important phase of conceptualization of the digital representation. The main core of the digital representation is to represent an ocean energy system by means of digital objects. Each digital object belongs to one of the three design components, which means that either it's part of the operating environment, or it's part of the physical domain, or belongs to the process domain. Each digital object will be described taking into account two model perspectives, a set of design parameters and a set of measures of performance or assessments. Moreover, as much as possible, for each digital object, we maintain the same structure, which means that each digital object is described by an identifier, by some parameters related to the location, a set of properties, and a set of connections with other objects. The structure of the digital representation follows, therefore, one of a rooted tree. We have a root, which is essentially the project. We have a first level set of children, in this case, the environment, the technology design, and the phases. A set of second level branches, for example, in case of the technology design, device, power transmission, station keeping, and on and on with a deeper level of detail. This is, for example, the technology design family. As you can see, we have the root, which is the array, device, power transmission, station keeping as the first branches, and each of them with a set of other objects. You can see that each of these boxes is a digital object and is described by one by set of fields as described before. But this is the vertical dimension is not the only one, as in the same family there will be a set of different objects of the same at the same hierarchical level. So the digital representation also must be able to capture relationships between elements at the same hierarchical level. For example, in an array we'll have several devices which are connected with for example, just one station keeping system, and each device is connected with more elements of the station keeping subsystem. This is particularly complex, therefore, to show the intra and inter-array relationships. As for the implementation, it was chosen to make out of each ocean energy project a file. The DTOceanPlus tool set of tools can be run whether in integrated mode or in standalone mode. In each of these modes, the user is able to export a file describing the digital representation. As for the format, the output file will be in JSON format. We have chosen this and not using something more specific for the DTOceanPlus project, essentially because this is widely used, can be commonly used whether in Excel or in any other kind of software opening simply text file. We can provide a schema for the data, and also we can make reference to several external files. Just to make an example of the implementation, in this case, you can see we have 3 different studies in standalone, but will be the same if we go in integrated mode in design and assessment. If I try to open one of them, I can just click on, I've already run of course, the case. You can open it in the energy transformation tool and see, for example, as the analysis already run, the different analysis. Once we have exported, once we can create the digital representation. And simply by clicking this, you will be able to download the file. We can go on show the digital representation. This is the one that we have already created. Go on download and you will be able to download. To open this digital representation, as I said, you can use even a simple text file, but online there are several also Json viewers. This is essentially the raw file, and this is the true viewer. As you can see here, the data is grouped into the digital objects. We have the array object, we have the device object, and we have the PTO object. Each PTO object will have grid conditioning objects, electrical conversion object, and mechanical conversion object. I mean, again, this is the case of the use in a standalone mode. If I go, for example, to the array, you can see that we have an identifier, we have a set of assessments, and a set of properties. Among the properties, for example, we have the array mass. The same structure, for example, if I go to the grid conditioning system, if I go to the first one, will be characterized by an ID, a set of assessments, and a set of properties. For example, the grid conditioning mass will be with a value 5,000. So in integrated mode, the functionality consists in merging the results of the digital representation of all the different modules into one huge JSON file. And of course, the results will be automatically merged. So we think that this is a first attempt to achieve a standardized approach for the description of ocean energy project. And we are looking forward to hearing your opinion about our approach for the digital representation. Thank you very much for your attention, and talk soon. Bye.